Okay, now for some practice using mean, median, and mode, now that you've gone through the vocab. I know these are all things you've seen before, but we're going to spend a little time just to review to make sure that you've got it. So, first example, straight out of your book, so if you want to open your book to go along with it, you can do it right here, it's fine. It says use the readathon graph at the right here. Find the mean, median, mode, and range. So, to remind what that looks like here, we can see that we have Nick read 40, Bettina 45, Kyle 48, Larry and Marita both 50, and 59 for Latana. So can find the mean, right? There are 1, 2, 3, 4, 5, 6. So that's going to be the denominator. There are 6 people here that read. And we add up each of their numbers. So add up all their numbers and then divide by that 6. Again, the total divided by the number of numbers. And so we get about 48.7 here. Now the median, to find that, you line all the numbers up, even if there's repeats. All the numbers, smallest to biggest. Again, even the repeats, because notice 50 appears here twice. And you find the middle number. Now here's the thing. This one does not have a middle number. If it did, if there was like 7 numbers, you'd pick the middle number. But there's not a middle number. So we have to take the 2 middle ones and find their mean. Right? So average them. So you add the 48 and the 50, divide by 2 to get 49. So here the median is a number that doesn't even actually exist in the list. Mode, find the data value that occurs most often. 50 occurs most often. So mode's like the easiest one to find, right? Sometimes there's more than one mode, and we'll discuss that too. And then the range, that's the biggest value minus the smallest value, and so that's 19. And we use that sometimes when we discuss, well, how spread out is the data, and that sort of thing. And we'll have that discussion later. But again, finding mean, median, mode, and range. So pause here, jump into Class Kick, and I've got a couple problems for you to work. So you should have gone into Class Kick and worked this one. You can find the mean, median, mode, and range of this set of data. Before I even start, I'm going to put them in order smallest to biggest, because that's useful for a lot of reasons. So we'll start there. I'm going to have 2.3. There's another 2.3 there. There is 2.7. So if you haven't done that, maybe go back and do that first. Let's see, 2.9 is next. Again, going smallest to biggest. 3.2 and 4.3. Alrighty? So there's smallest to biggest. So the mean means I add those all together. So I'm going to add up all these numbers, which is, so I'm going to put the mean here. So that's 17.7 when I add them together and divide by 6, because again there's 1, 2, 3, 4, 5, 6 numbers. So we can add those all together for the mean and divide by 6, and then we get 2.95. Median, once we've put them in order, that's easy to find. So there's 6 numbers, so it's going to be between these two. Now again, if there was a middle number, you'd pick that, but there's not. So you have to add those 2 middle numbers together, the 2.7 plus 2.9 divided by 2, which is 2.8. So the median is 2.8. Mode is the most frequently occurring. Sometimes there's not a mode, sometimes more than one mode, but we can see here that 2.3 appears twice, and that's the only one that does. So 2.3 is the mode. And then my range is smallest minus, or biggest minus smallest, so 4.3 minus 2.3. Which is the number 2. Okay, so mean, median, mode, and range. Continue for another example. Okay, so we have here, how many modes, if any, does each have? So, here we have, if we look at these, none of these repeat. So there is no mode. On B, take a look at all these numbers. 8 appears twice, 14 appears twice. So it has 2 modes. 8 and 14. Now the great thing about mode is we can also use it when we don't have numbers. So we just have words. So like here, grape, so it might be favorite fruit, I don't know, grape, banana, nectarine, strawberry, orange, watermelon. Strawberry is the mode. So there you go. Mode for each of these different ones. So again, something to remember, mode is the only one you can use when you don't have numbers. So you can't like find the mean of these and go, oh, so I want the average of grape and banana and nectarine. Maybe that average is some fruit I've never heard of before. You can't do that. You can't average eye color or hair color, things like that. All the others can use numbers, but mode is the one that doesn't have to have numbers. Remember that. That might be a quiz or a test question. So pause here, go back to class kick and worked one. I'll be watching. Okay, so on here, I can see the answers there obviously, but let's talk about the number of modes. So let's see, what appears there? So 11 appears twice, right? And I see 8 appears twice, and 7 appears twice. There's actually 3 modes here. Now, if one of those, like 8, had a third one, that'd be the mode. The other ones would be out. But because they're all equal, that's what it has. Now, if I take a look at B here, what appears most? Let's see, a 38. I got a 38.5 here that appears twice, and nobody else appears twice, so that's the mode, is 38.5. And again, you don't have to do anything with it, just state it. It's the mode. There's like no math actually involved with it, other than counting the number of them. Continue for, I think, one more example for me. Now this one's one of my favorite of these, is the idea of an outlier. Because we look at this, and I'm kind of a data geek, but if you look at things that, like, you look at averages among people, you know, incomes or ages or things like that. So think about this. If we were to take a look at all the people's ages in the classroom, right, when I am in your class, I would be the outlier because I'm like way older than the rest of you. And if you were to use that when you tried to average, it would throw off the average. It would look like there were older people in the classroom than there are. But if you take me out, the outlier, right, then that doesn't count anymore. So that's one of those things I think are kind of fun. You think, oh, look at this one. It's way different than the others. So I'm like way older than you guys. So that would mess up the average. Okay, so on this one, it says, use the map of Central America at the right. Which data value is an outlier? So the data value for Honduras, 6,500, is an outlier. It's an outlier because it is 1,500 miles away, squared rather, from the closest data value. Outliers can be bigger or smaller than the rest. So, and they're significantly bigger, right? So if you take a look here, there's 5,200, 6,500, 4,500, 2,100, 1,200, 2,200. And they're saying that Honduras at 6,500 is an outlier. Now, I might argue that this Belize being so small might be an outlier on the other end, too. Sometimes you can have more than one outlier, but, you know, so again, if you can make the argument, that's the biggest thing. So how does it affect the mean? So again, that's kind of the fun part here. So if I take out, so if I add, there's 1, 2, 3, 4, 5, 6, 7 countries, right? It's kind of, again, to make sure I get that right. 1, 2, 3, 4, 5, 6, 7 countries. So if I include it with the outlier, right? So I include that Honduras, that one's way bigger than the rest, in here. The outlier, the average area is 3,100. But if I take it out, because it's so much bigger than the rest, the average drops to 2,500. So there's a 600 square mile difference, including that outlier. That's how much it affects it. So an outlier has that effect on things. So that's one of the things to look for. Kind of like the bowling score example that you're going to see when we do. Actually, it might have been in your. I guess it was probably already in your mean median mode. You throw it. There's an outlier in there. One really good day makes you look like you're a better bowler than you were otherwise. Again, just like my age being part of the classroom. If you're going to average them, it throws it off to so much more because, you know, I'm obviously 100,000 years old. So, all right, head in class kick for some more problems for you to work. Again, I'll be watching. Okay, so here you're supposed to find the outlier and then tell how it affects the mean. So on this first one, clearly 31 is way bigger than the rest of the numbers, so it's an outlier. I mean, look at the numbers. It is so far away from the others and so much bigger. But if I include it, right, there's 8 numbers. So if I include that 31, there's 8 numbers, and they add up to 101. Again, this is including the 31. So that means the mean here is 12.625. Okay? If I don't include it, so I take the 31 back out, it adds up to 70, and there's only 7 numbers to divide from, right, because I removed it. And that means my mean is 10. So you can see by including the 31, my mean increased by 2.6. Well, 2.625. Now over on the second one, so the outlier is clearly a 1 here, right? It's way smaller than the rest. If I include it, my total is 89.5, and I have 6 numbers to divide by, and that gives me a mean of 14.9. Now, if I don't include it, it's 88.5 because it's only 1, right? But I have only 5 to divide from, and that gives me a mean, oops, there we go, of 17.7. So you can see that my mean will decrease, right? It lowers it if I include that one by 2.8. So it actually brings it down. So there you go. That's what we're looking at here. And again, that outlier can greatly affect it. Here you can see that the outlier raised the mean. Here you can see the outlier lowered the mean. So brought it down because it's so much lower than the rest. So think of this for this is really important actually. Think of this for test scores, right? Or performance scores. And you did really bad one day. And it brings you down quite a bit. So that's why I always tell you, do your best on stuff and redo things because you can bring your average down a lot with one bad score.